Hello, honor statistics. All right, this is going to be your notes for chapter 9.1, dealing with our very first lesson of hypothesis testing. We are going to be dealing with hypothesis testing around mu, okay? Around mu. So, with that said, let's take a look at our first example. I'll give you the vocabulary with it with our first example. It has been reported that that the average credit card debt for college seniors is $3,262. Guys, it's reported that the average, this is all seniors probably in the United States. So they're trying to tell you that our mu, our population mean, is $3,262. The student senate at a large university, so this is a sample, feels that their seniors have a debt that's much less. Hey guys, less is going to be a very important part of this lesson. So it conducted a study of 50, so now we know what N is. N is 50. Randomly selected seniors, and they find the average debt is $28.95. Now remember, that's the average debt from the 50 seniors, so that's our X bar. X bar is 2895. And the population standard deviation is $1,100. That is our sigma, $1,100. Those are the 4 pieces of information that you will need in order to do a hypothesis test. Well, where does a hypothesis test come from? It says, can we support the student senate's claim using the data collected? So their claim is their students have less debt, okay? So, again, remember this first problem, I'm going to give you notes. The first thing you have is called a null hypothesis. A null hypothesis is denoted by H sub naught. It is always going to be mu equaling whatever they gave us for the mu in our problem. In this case, it's 3262. Our alternate hypothesis is the second thing you need to find. It's denoted by H sub 1. It is also about mu, but this is where the less than comes into play. Less than 3262. So our hypotheses, null and alternate. The null is always equal. The alternate can either be less than, greater than, or not equal to. We are obviously doing the less than right now. I will be doing those other 2 in this video in a little bit. Okay, our next step after our 2 hypotheses is we must find our test statistic, which in this case is going to be our Z. It's going to be a Z of X bar, but it's still a Z score like we always have. Our Z score has a formula, X bar minus the population mean divided by sigma over the square root of n. So in our example, X bar is the 2895. Take away the mu, which is 3262. And you guys can see 2895 is actually smaller, so that's why this is a less than problem. Our sigma is $1,100, and there were 50 total people in that particular college, our N. It's a z-score, so you know that you have to round to 2 decimal places. And plug in the calculator, we get negative 2.36. That is our test statistic for this example. Now, with every single hypothesis testing, you are going to be required to draw a standard normal curve. And you need to be able to plot approximately where that test statistic falls. In this case, it falls about right here. This to me is negative 2.36. What we're looking for now is a p-value. A p-value is the percentage coming from your test statistic that will help us prove if our null hypothesis is true or false. The p-value is very simple. It is this percentage right here. Less than. This is a less than problem. Now, hopefully you know when you pull out your z-score chart and you look up negative 2.36, what it says in the body of the chart is what's to the left. So I look it up and I see 0.0091. So the p-value in this problem is 0.0091. There's a thing called level of significance. Okay. A level of significance, our sigma can either be 0.5 or 0.1. We're going to concentrate on 0.5. That's 5%. This is how we compare if our p-value is large or small. So hopefully you can see that p-value is small. It's much smaller than 0.5. Let me kind of put this in layman's terms first. If the p-value is small, you are going to reject H naught. If your p-value is large, you are going to fail to reject H naught. It's weird. You don't want to say accept the alternate. You have to unfortunately say fail to reject because that's what's in question. Is the 3262, is that average going to be for every college in the world? Okay. So now, those two things right here, this is kind of like, teaching. Let's go back to our problem. Here's the answer, official answer to the problem. You must first say, since the p-value of 0.0091 is small, remember level of significance is 5%, so it's below it, we reject H naught. And now we have to put it into words. Okay, those are a blanket statement. So now the words according to this problem. There is evidence to support the seniors at that college, obviously, debt is less than 3262. So if you go back and look at the alternate hypothesis, that's the one that's going to be true. Because if you reject H naught, that means H1 is true. And if I just come up here real quick to H1, and you see it, H1 says mu is less than 3262. So therefore, since you rejected H naught, there is evidence to support that the seniors at this particular college debt is less than the average of $32.62. So let me reiterate a little more about level of significance. If I said this problem, and it'll say up in the original problem, please do the problem with a level of significance of 0.5 or 0.1. If I chose 0.1 to be the level of significance, and you got this answer, notice that that's still smaller than 0.1. So the answer would be exactly the same. You would still reject H naught, and you would accept what's happening in the alternate hypothesis. If you have a less than, you're going to have a one-tail test, and it's actually called a left tail. And you can see that's the left side, okay, the left tail. Which means, guess what my next problem is going to be? So we just saw an example of a less than. Example 2. The Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,672. So since this is coming from an education foundation, they've been doing research for a very long period of time, and that is our population mean mu, which is $24,672. To see if the average cost of rehabilitation is different, when you see this word different, that doesn't mean greater than, that doesn't mean less than, this means it could be more or less. So let's hold that thought for a moment when we get to our alternate hypothesis. A researcher selects at random 35 stroke victims, so therefore N is 35, at a hospital and finds the average cost of their rehab to be $25,250. So that is our X bar because that is an individual hospital, $25,250. The standard deviation of the population, so I just gave us sigma, is 3251. And the question for the hypothesis testing is this: can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from that $24,672? So we have our 4 bits of information. Let's do our null hypothesis first. Mu is equal to the 24,672. It's always equal to. Null is always equal to. Then, ladies and gentlemen, our alternate hypothesis, remember I told you it's 3 things: less than, greater than, or not equal to. This is a not equal to. Keep the same number, 24,672. We're still going to find our test statistic Z. I'm not going to write the formula this time, but I'll say it as I write the numbers in. It's X bar, 25,250. Take away mu, 24,672. Divided by sigma, 3251, which is divided by the square root of n, 35. We plug this into Mr. Calculator and it spits out a 1.05. Again, we're going to look at a level of significance of 0.05. I made this one come out to be a number like this. Okay, now we have a little bit of teaching before I finish this problem. When you have, and I'll do it here and erase it, when you have less than or greater than in your alternate hypothesis, these are considered to be a one-tail test, right? Less than is considered to be a left tail. Think about it. Remember the problem we did before over here? That's the left tail. That's the end. A greater than is considered to be a right tail, a right tail. That's this piece over here. Okay, so with that all said, what's going on with a not equal to? A not equal to, which is the problem we're doing right now, is considered to be a two-tail test. So 105, I think, is about right here, 1.05. But everybody, since it's a two-tail, we have to also test negative 105. So that means I'm looking for this percentage and this percentage, and our p-value will be them added together. Now, if you think about it, I would prefer looking this one up on my chart because it gives you what's less than. When I look it up, I get a 0.1469. That means this is also 1469 because it's symmetrical. So, ladies and gentlemen, our p-value for a two-tail test, the one where your alternate hypothesis is not equal to, is going to be 2 times the 1469, or 2938. So therefore, within my first 2 examples, I want you to see the 2 different things that could happen to the null: reject and fail to reject. So our first statement, remember, we're comparing this to the 0.5 significance level, and we can definitely see that it's what? It's bigger. So you will say, since the p-value of 0.2938 is large, comma, we fail to reject H naught. Let me pause this right now. So now the verbiage answer for this problem where we are failing to reject. That means our H naught is a correct statement. So there is not enough evidence to support the average cost of stroke rehab will differ. So there's not enough evidence to support the average cost of stroke rehab will differ from the 24,672. Okay? So it's either going to say, will differ from, will not differ from, or you can just say it's going to remain 24,672. So let's reiterate a couple things with our first 2 examples. You're always going to compare your p-value with the level of significance. Right now, 0.5 is the one that we are going to be using. If we have a not equal to, then you have a two-tail test. Let me go back. I bet you it's going to mirror it on both sides. And then everybody, you can have a 0.5 significance level or 0.1 significance level, and you will compare the p-value that you get, which is the percentage from your z-score chart, and you will figure out if it's large or small. If it's large, you will fail to reject, be greater than. So here we go. A nutritionist believes that a 12-ounce box of cereal should contain an average of 1.2 ounces of bran. That's our mu. 1.2 ounces. She suspects that a popular cereal has a larger mean bran content. She carefully analyzes the contents of a random sample of 20 12-ounce boxes of cereal. So now we know N is 20. And finds that the mean brand content is 1.26 ounces. That's our X bar, 1.26 ounces. As you can see, it is a little bit larger. It is known that the standard deviation of brand content of all such boxes is 0.08. So that is our population standard deviation, 0.08. And now our question. Do the data provide sufficient evidence to conclude that the mean brand content of all 12-ounce boxes of cereal is more than, I put then, more than 1.2 ounces? Okay. So here we go. We have all of our pieces of information. So we have to set up our null hypothesis, H naught. It's claiming that mu is going to equal 1.2 ounces. That's what it claims. Our alternate hypothesis, mu is greater than 1.2 ounces. All right? Because remember, X bar was 1.26, which is a little bit larger. So therefore, we have to find our test statistic for that 1.26. So 1.26, take away 1.2, divided by 0.08, and the square root of 20. Doing this, I get 3.35. Now, a greater than, you just have to be a little bit careful, because when you draw your standard normal curve, positive 3.35 is way over here, 3.35. Remember, this is called a right tail test, right tail. Notice I haven't given you a level of significance yet, because I want you to see something, because this is going to be a very small number. Now, what I said, you have to be careful, because when you look up in the body of the z-score chart, it's going to give you the number to the left. 9996. 9996. That's obviously not my answer. Subtract from 1, and we get 0004. Therefore, our p-value, since this is a one-tail test, i.e. right tail, is 0004. Which means, guys, if I gave you a level of significance of 05 or a level of significance of 01, what's true about 0004? It's less than either one, okay? So I'm just trying to let you know that I'll throw the level of significance in according to the type of question, all right? The one we did previous, that number was so large, it didn't really matter, okay? So here comes the blanket statement. Since the p-value of 0004 is small, we reject H naught. Okay. See, the only thing I can give you like a hint, everybody, see the word small? You only write one thing. But when you write the word large, you write fail to reject. So when you write the word large, you're going to write more words. Fail to reject. Small, just write the small, reject. So if that helps, it helps. If it doesn't, oh well. And now the scenario for the problem itself. There is evidence to support the mean bran content in that particular cereal, in the cereal, is more than 1.2 ounces. So they're trying to say, excuse me, that because of that little study that they did, and she found 1.26 ounces in those boxes, those 20 boxes, that there's a good chance that more boxes have a little more bran than what normally is called for. Okay? So, just a verbal wrap-up of 9.1. You're going to be given a problem. In that problem, you are going to be given 4 pieces of information: mu, n, x bar, and sigma. The only other thing that I can do different, and the book can do different, everybody, is instead of me giving you x bar, I give you what? The actual data pieces. So in this problem, I would give you actually 20 data pieces that you would add together, divide by 20, and you would get 1.26. That's the worst thing that the book can do in comparison to what I have done. But you will receive those 4 bits of information: the population mean mu, the number in our sample, the sample mean, x bar, and sigma, the population standard deviation. From there, you are going to write 2 hypotheses. The null hypothesis always has an equal sign, and the alternate hypothesis can be less than, greater than, or not equal to. From there, you will find a test statistic called z by doing a formula x bar minus mu divided by sigma over the square root of n. It'll yield a z-score. With that z-score, you're going to draw a standard normal curve. You will plot the z-score. If it's greater than, it'll be positive and to the right. If it's less than, it'll be to the left, it'll be negative. If it's not equal to, it could be positive or negative. But who cares which one I give you, because you have to. If it's small, you will reject. And then one more sentence about the problem itself. And ladies and gentlemen, that is 9.1.